So we are going to be working on practice exam 4 in this video. The problems number 9 and 10 and the 14 through 18 are 13-14 questions, so that's going to apply to your 13-14 grade. So the first section says solve the following quadratic equations using factoring. Let's just take a look at where we're going next after this. The next are solve quadratic equations using square root method. Then after that, we're going to solve quadratic equations using completing the square, and then solve equations using the quadratic formula. So these are the 4 methods of solving quadratic equations, and because I'm asking you to do the specific method on each one of these, I don't want you trying another method in a different section. I'm trying to test to make sure you know all of the different methods. So please, in this section, we have to use factoring. So I'm going to subtract 10 on both sides so that I can get one side equal to 0, and then I'm going to factor. In this case, because it's a hard trinomial, I'm going to use guess and check. So I have 1x and 3x, and that's the only thing we can use on that side. On the other side, I got 1 and 10 or 2 and 5. Now, if you want to use grouping, you're welcome to. I just find this one a little bit faster. Okay, so I'm going to try 2 and 5 first. When I multiply across, I'm getting 6x and 5x. Let's see, with one of each sign, because there's a minus, that means one of each sign, I have to add to a positive 1. So a positive on the 6, a minus on the 5 is going to add to a positive 1. And I got it factored on the first try, so that's awesome. So I have 1x plus 2 and 3x minus 5 equals 0. Now using the zero product property, I'm going to set each of the two factors equal to 0 and solve. So I'm getting 2, negative 2, and positive 5/3. And that is my answer. I do not need to check these. On the next problem, I'm factoring again. I need one side equal to 0. Because the 81x squared is already positive, what I'm going to do is I'm going to move the 243 to the other side. Now, sometimes you can use transposition by just picking it up and moving it to the other side. It's going to save you a little bit of time. Okay, now I have to factor. Now there's only 2 terms here, so a lot of times people are trying to use difference of squares or difference of cubes or sum of cubes, but it's actually a way more simple than that, and I can guarantee you that a lot of people want to do a harder thing on this, and it's just an easy, simple thing, and I was trying to give you an easy problem here, and sometimes people really mess up the easy ones and get the harder ones. This is just a GCF. What can come out of 81 and 243? Well, they both can be divided by 81. What can come out of x squared and x? X. That's as simple as it is. So 81 divided by 81 is 1. X squared divided by x is x. Negative 243 divided by 81, that's negative 3. And then x is divided out. And that's as simple as it gets. But a lot of times people do some very creative math, and that's wrong here. So now I'm going to set each of the factors equal to 0. And solve. So when I'm solving for 81x equals 0, I just divide both sides by 81, and I'm getting x equals 0 divided by 81, which is just 0. Then I add 3 to the other side, and I'm getting 3. So my 2 solutions are 0 and 3. Okay, so for the next section, it says to solve the quadratic equation by using the square root method. So I'm going to take the square root of both sides. First thing I want to do is make sure the square is all by itself, and it is. There's nothing being added or subtracted outside the parentheses or multiplied or divided. So I'm going to go ahead and just square root both sides right now. So that gets me 4x plus 3 equals the square root of 20. Now, whenever you take the square root of both sides, you have to put the plus or minus part in the front. Okay. Let's see. I can solve for x by subtracting 3. So that gets me 4x is equal to negative 3 plus or minus the square root of 20. And then I'm going to divide it all by 4. So I have x is equal to negative 3 plus or minus the square root of 20 over 4. Now, before I can finish this, the square root of 20, that needs to be reduced. So it's 4 times 5, 2, 2, and 5. So that's negative 3 plus or minus. The 2 goes out of the radical. The 5 stays home over 4. So at this point, I have to determine if it can reduce some more. So we have 3, 2, and 4. Can 3, 2, and 4 be reduced or divided to have a common factor? No, they can't. So this is my final answer. I do not have to break it up at all because there is no I, so I don't have to split it up. I'm just going to leave it that way. Technically, you could split it up to negative 3/4 plus or minus 2 root 5 over 4, but then 2 root 5 over 4 would need to be reduced. So I would just leave it that way. I think that's the easiest way to do it. On the next part, I need to get the square all by itself. It already is, so that's good. So I can go ahead and straight square root both sides. The square root of x squared is just x. The square and the square root undo each other, which was the whole point of doing it. Equals, don't forget your plus or minus, root negative 80. So I have to reduce root negative 80. Because there's a negative, I know we're going to have an I. So let's see what else we can get here. So we have 4 and 2. 2, 2, 2, 2, and 5. So the 2 comes out, the 2 comes out. The 5 stays home. So that's going to be 2 times 2, 4 square roots of 5. So my solution is plus or minus 4i square roots of 5. And that's it. Notice all quadratic equations are getting 2 answers. Okay, so plus or minus is the one that's getting you positive part and the negative part, which is again 2. This next section says to solve the following quadratic equations by completing the square. So in order to complete the square, I'm going to move all of the x terms to one side. So I'm going to minus 4x to both sides, or just pick it up and move it over. Then I'm going to leave a blank. Now the negative 7 was already on the right side, and I'm going to leave it there. All I want is the x term, so the x squared and the x term I'm going to put on the left, the number I'm going to leave on the right. The rule here for completing the square is divide by 2 and square. So when I divide negative 4 by 2, I'm getting x minus 2 quantity squared. Okay, the squared comes from when I factored it, I'm getting x minus 2 times x minus 2. This only works if I have the perfect square in that blank. So negative 2 squared is positive 4. So I'm the one that added the 4 to the left side so that it would factor into x minus 2 quantity squared. If I add 4 to the left, then I have to also then add 4 to the right. So in that 2 steps right there, I've changed my problem into a square root method problem using completing the square. So the rest of this, I'm just going to square root both sides and do the same thing I did on problems 3 and 4. So when I square root, the square and the square root undo each other, and I'm just left with the inside x minus 2 equals plus or minus the square root of a negative. The negative comes out and becomes an I. Square root of 3 stays home. 3 doesn't have any perfect squares in it, so there's nothing you can reduce there. And the last thing I need to do is add 2 to both sides. At this point, sometimes people put the 2 behind the plus or minus, but that's wrong. So I would recommend putting the 2 in front, then the plus or minus I square roots of 3, and that's going to be your final answer. And then someone else is going to say, do I really have to put it in the squigglies? Probably not. If you left it x equals, I'll give you the credit for that too. All right, one more completing the square problem. The 12, the plus 12 needs to go to the other side. So I have x squared minus 12x. Those are the x terms. Then I'm going to put a blank. I'm going to pick up the 12 and move it to the other side. That becomes negative 12. Or you can think of it as subtracting 12 from both sides. That'll work as well. My steps are divide by 2 and square. So when I take negative 12 and divide by 2, that's negative 6. Square negative 6, that gets me 36. Now x squared minus 12x plus 36 does truly factor into x minus 6 quantity squared. So I forced that to happen. But by forcing it to happen, I added 36 to the left. To be fair, you got to add 36 to the right to keep everything even. Negative 12 plus 36 is 24. And I'm going to square root both sides. So I have x minus 6 equals plus or minus the square root of 24. The square root of 24 I know is going to break down, so let's go ahead and do that now. The 2 comes out, the 2 and the 3 stays home. So that gets me plus or minus, the 2 comes out, and 2 times 3 is 6. And then my last step is to add 6 to both sides. So I get x is equal to 6 plus or minus 2 square roots of 6.